In this video, we'll be considering the format of tables themselves. Now, the traditional format is based on publishing books before computer technology, when it was very hard to line up vertical lines in the handset text. And so this is based on the old typesetting methods. But it actually is easier to read if there are not lines and boxes, because it's easier to compare, to know which items you ought to be comparing and how. Now again, in engineering, you'll see a lot of things that don't follow the sort of expected guidelines, partially because they're published quickly and they care about getting the information out rather than format. But it's still useful and it makes them much easier to read if you follow the standard format. And so that's why the standard format exists. It doesn't take a lot of time to do it, make it easy for your reader. So the standard format is no vertical lines. You have a bold horizontal line at the top, a bold horizontal line at the bottom, and then usually a line between the heading for the columns and the columns themselves. Most of the other formatting should be done using spacing rather than lines, just to make the image less cluttered. Also, if you're using a unit in the column, it's placed in parentheses on a separate line after the main heading for the column. For a row, it's placed in parentheses, but frequently in the same row as the general description, the title. Okay, so numbers are easier to compare in columns because of the placeholder setting of numbers. However, words are easier to compare in rows. Let me give you an example. Okay, if you're trying to read this and compare these numbers, you have to look at each one individually to find out which is larger or smaller. But if I put the exact same numbers in a column, then it's very easy to compare. You just see which one is longer and you can tell which one is the higher value. Also, if you're using numbers, it's best to align them on the decimal, not centered in the column. Again, this is just making it easier for your reader to see the place value and to compare the numbers. With words, we tend to read English words across a row. And so if you put the words that you want to compare across, people will normally read across. If you put those words up and down, then people are going to read English, so words, rows, wait. And then they realize, oh, I should compare this vertically, but it's not our natural way of reading. So this is a well-formatted table, and you can see that it includes all the features that I talked about. It has the unit on a separate row in parentheses. It rounds all the data to the same number of decimal places or significant digits. And for Chinese particularly, pay attention that you don't split words across a line in the heading. Make your column wide enough so you can get the words all there. Because if you have something like separate ion, people are going to wonder what that is. You can divide Chinese characters, you can write Chinese characters vertically, there's no problem. But English words, if you have to do this, use a proper hyphenation or an abbreviation or something in order to put it all on one line. And eliminate blank space, but use the blank space. For instance, here, there are some blank spaces after each of the main names of the arrays so that you can separate them easily by group. But don't have unnecessary blank space. And in some cases, with a publication, with a web page, something like that, you need to consider the column size. Do they want it only one column? If it's a two-column publication, it has to be either one or two, not 1.5 columns, so they don't have the problem with text graph. Again, this is different in a thesis or other situations, but this is the standard format for a journal article. Now, there are many tables and figures that are published that are not good. And again, this is much more common in engineering because they're just trying to get the data out quickly than in social science and humanities, where they're much more careful about the writing and the formatting of things in tables and figures. So here, this is a situation where the author is comparing their work with other previously published work. And what they've done is they have copied the exact numbers that are listed in that other publication. And so you have different levels of precision, but that's confusing. Also, you see that in one place in the second column, beta, they have 1.6 times 103. Oh, really that should be 10 to the third, but somehow in the formatting, the exponent got dropped. It's no longer a superscript. And if you look at 1.6 times 10 to the third, that's 1,600, which fits right in the same range as the others above that. So there's no reason to use this exponential notation. It's confusing, makes it harder to compare.
Actually, this kind of confusing problems is not restricted to engineers only.
Oh, that's good. I'm glad to hear that.
Yeah, social scientists, if we don't pay attention to the decimal alignment, we can also make a similar mistake like what you described. So we are not that perfect.
That's good to know. Okay, in this bad example, you can see that they have put something in parentheses in the column headers, but what's in parentheses is not the unit. The unit, for instance, for the second column should be milliseconds. And that's what should be in parentheses, not the search time. They have the variable name in parentheses, and again, that makes it confusing. Also, the BPS and the MPS, those are actually the things that they are adding, their new designs, and they've hidden them for some reason in the middle of this table. I've never been able to figure out why. And here's another one. If you were to look at this table, could you figure out what you're supposed to be comparing? No.
No.
It took me a while too, so don't feel bad. They're comparing A1 to A2 to A3, D1 to D2 to D3, etc. And so they just put this in a random table, but it's very difficult to compare. So let me show you how this could be improved. You're trying to compare A1, A2, A3, and they're numbers. So it makes sense to switch the orientation so those are in a column, and then put the A, the D, the phi, the theta in different columns. So I've done that here, and you can see I have the superscripts on the rows and AD, phi, and theta across the top. And now it's very easy to compare the differences. And you can also see very clearly that you're missing something, because many programs, if it's 0.0, when it graphs it, it will not put that 0.0, even though it was measured. So you need to be aware. I'm assuming that those should probably be 0.0, but I don't know. And so it's important to check your figures, check your numbers in the table to make sure that everything is shown.
This illustrates why a good table is better than thousands of words.
Right. Now, for a PowerPoint, you've probably noticed the tables in PowerPoint are very different from the tables in a book. Okay? Now, the reason for that is in a book, we're usually trying to use as much black and white as possible. It's easier to see, it's easy to compare. But when you look at a presentation, a PowerPoint, and you're trying to get the information quickly, it's much easier to see if it's somehow colored. So one thing that you consider when you're making the PowerPoint tables is highlighting. If you want people to pay attention to the second row, that's actually the best. And it's therefore you can put the numbers in color, you can put the cells in a different color, or you can use something like a shape with an animation to call your reader's attention to that, rather than using the laser pointer and then hoping that they're looking at the time when you're pointing. Now there's some tables that don't seem like they're really necessary. For instance, table 4 here. They have 5 houses and an overall, and they have overvoltage at 1 minute and 15 minutes and normal at 30 minutes for everyone. So this would be easily summarized in one sentence. Every house showed an over voltage at 1 minute and 15 minutes and returned to normal by 30 minutes.
Unless you want to illustrate that I have good data, I have evidence to show you that they are all the same. Let me provide a table to illustrate that. In that case, it's not unnecessary.
Right. And in engineering also, people will use tables like this to make it easy to find. Because if you have to read the whole text, people will miss a lot of things. Whereas they can skim very quickly from one table to another, look at it very quickly and get the big picture, and then know if they want to read for the greater detail. So again, in the next video, the last one in this unit, we'll be looking at how to improve figures.